Good morning. Today, in artificial intelligence and soft computing, we'll see different things in a best first search strategy. In the last lecture, we have discussed a hill climbing algorithm, which is one of the informed search strategy, and we have discussed different issues in a hill climbing algorithm. Now, in this lecture, we'll study a best first search strategy. As the best, the name suggests, it is the best first search. Means the best node should be searched first. So let's see what is a best first search strategy and how a best first search strategy will be implemented. So a best first search strategy is one of the informed search strategies. So it also has the three type of information, that is nothing but the initial state, that is nothing but your goal state, as well as whatever the hint information available on each of the particular node. As we have discussed, the best first search strategy is nothing but the strategy which is visiting the best node first, and then it is going to search according to that particular process. So now, as shown in this particular tree, we are having a certain nodes with certain heuristic values. So this is a particular node which is the initial node from which we will start a searching process. So we'll open this particular strategy can use a stack data structure or it can use a queue data structure. But here for a discussion we are taking a queue data structure. So we'll start from this particular node. We'll open this particular node and we'll check whether this is a goal node. If this is a goal node, we'll print succeed and we'll stop there. If this particular node is not a goal node, then we'll open its successors one by one and we'll add them into a queue. Okay, here we are opening its successors one by one and we are adding them into a queue, and then we are performing a sorting process. Okay, we'll arrange them in such a manner that a best node which is according to our heuristic value will come, or according to our heuristic function will come at the front end of our queue if we are taking a queue data structure. So if this is not a goal node, then we'll open its successors, we'll add them into a queue and we'll sort them in a manner so that the best node according to our heuristic function will come at the front end. According to this particular tree, this is a worst node which is not promising, which is this node is not promising. The most promising node is nothing but a C, means which is having a maximum success rate, or which is a best node. So this node will be placed into a queue first, then this, and next this node will be placed. Means this particular node will come at the front end of our queue and we'll cross check this node first. If this node is a goal node, then print succeed and stop there. If this node is not a goal node, then check whether it is having successors. Yes, it is having successors. So we'll open these successors, we'll place them into a queue, and now the difference between this particular searching strategy and hill climbing is this: we are adding these open successors into a queue and then we are sorting whatever element present in our queue, including the previous elements and these particular newly open elements, and we'll sort that particular queue in such a manner that the best node will come at the front end of our queue. Now a best node which is at the front end of our queue is nothing but a G. We'll cross check this particular node. If this node is a goal node, we'll print succeed and stop there. If this node is not a goal node, then we'll check whether it is having successors. If it is having successors, we'll add them to a queue and then sort whatever element present in a queue. Now at this moment this particular node is not having any successors, so we'll close it and we'll concentrate on the next front end element of our queue. So now a next front end element of our queue is nothing but H, which is having a heuristic value 4. So we'll check whether this is a goal node. If this is a goal node, we'll print succeed and stop there. If this is not a goal node, then we'll check whether it is having successors. As it is having successors K and L, we'll add them into our queue and we'll check which one is, or will sort a total queue available, and the front end element, the next which will come at the front end, will again cross check across our goal node. Okay, in this way this particular search will be conducted. Here the basic logic is we are checking a particular node. If this node is a goal node, then we are printing succeed. If it is not a goal node, then we are opening its successors. We are adding, the important thing is we are adding them into a queue, and then we are sorting of whatever element present in the queue. We are not sorting first and we are adding into a queue, but here we are adding first into a queue and then we are sorting whatever element present in the queue, the currently added element plus whatever the previously available element in the queue, so that a best element will come at the front end of our queue and will cross check it. So this is regarding to a hill climbing, this is regarding to a best first search strategy. We'll see its steps. So step number 1 is a create a single member queue. Step number 1 is to create a single member queue, that is nothing but an open queue. Okay, then step number 2, if first member is a goal node, go to step number 5. Step number 3, if first member is not a goal node, then remove it and add it to the list of visited nodes. Open its successors if any, add them to the open queue and sort a total queue according to the heuristic value, such as the best element will come at the front end. Follow same process till goal node is achieved, or go to step number 6. Step number 4, if queue is empty, go to step number 6, else go to step number 2. Step number 5, print success and stop if goal node is achieved. Step number 6, print fail and stop. Okay, this will be conducted if the particular tree will be visited and a goal node is not available under your tree. Okay, so this is regarding to a best first search strategy. Okay, so some of the things we should know regarding to a best first search strategies are nothing but a best first search will explore a tree as long as it seems to be probabilistic, leading towards a goal state. Means we are exploring a probability, okay, all the nodes which are looking promising, okay, or switch to alternative branch if it seems to be more promising than the current. Means this is nothing but mixing of BFS and DFS. Okay, here we are going across one of the branch if it is looking promising, and if it is not looking promising, we are moving to a next branch, or we are jumping to a next branch. Hence it is neither, we are not neither expanding only a one branch, not a pure DFS, nor expand all the branches, not a pure BFS, rather expand branches when needed. So we can say it is a combination of BFS and DFS. Okay, so this is a best first search strategy. Okay, go through this and put your comment in a comment box, and please like this video if you like, and subscribe my channel. Thank you.